Hello, welcome to the 4.4 notes on proving triangles congruent by SAS and by HL. So today's objectives are to determine if triangles are congruent using SAS and HL and to prove triangles congruent using SAS and HL. So the first thing we're going to talk about is the side angle side congruence postulate. So what that is that if you have two triangles, let's label this one ABC, and then let's label this one DEF. Here's what you're looking to be congruent for side angle side. You have a side here congruent to a side of the second triangle. You have a second side and a second side. Now what's important is the order here. If I want side angle side, that angle has to be what's called an included angle. Okay, so this angle has to be the included angle. What does that mean? It's the angle between the two sides. It's the angle created by those two sides. Where those two congruent sides come together, that angle has to be congruent to the angle of the other triangle. So when you're looking for side angle side, you are looking in order. It has to be a side, then an angle, then a side. So you can't jump around the triangle and decide that it is side angle side when it's not. All right, so example 1 says, determine whether triangle ABD is congruent to triangle CDB. First thing you want to do when you have this type of picture, like we've had in the past few notes, is you mark that side that they share, you mark it that it's congruent. That's the reflexive property, that side is congruent to itself. So now we have to check if this congruency holds true. The order here, ABD, is you go side, angle, and then a side. So now we have to just make sure that the side goes consistently in order for the other one. So we went, again, this path, we went single tick on the side, angle marking, double tick. Let's see if the second triangle follows that same exact pattern. It's CDB. So single side, angle, double side. So you would say yes, triangle's congruent by side angle side. This is important because once we start reviewing all of them, you're going to have to specify which postulate or theorem you use to mark the triangles congruent. All right, so example 2 here says determine whether triangle YXZ is congruent to triangle WXZ. So again, the first thing I notice is that these two triangles share this side. So I'm going to double tick it. Now, the second thing I notice is that there aren't any arcs in any of the angles. However, there is this right angle down here in triangle ZXY, which means there's a right angle in the left triangle. So when I look at this picture, I see that the left triangle has two sides and an angle, and I see that the right triangle has two sides that are congruent and an angle. So we have to make sure that this order is correct and that it is side, then an angle, then a side. So looking at this triangle on the left, I have a side, then I have another side, and then an angle. Folks, that's what I call A double snakes, angle, side, side. If I was to abbreviate that, it would be a bad word. That is no good. We don't want to see bad words on your paper. There is no A double snakes, okay? So this one for sure is a no. Also, if you were to look at this right triangle, this one is side, then an angle, then a side, because remember you have to go in order, you can't jump around. That one is side, angle, side. But unfortunately, the wrong side was marked for this one that I kind of made in red. Okay, now it's in red, so they do not correspond to each other. All right, last example from these notes, we are going to check if triangle ABD is congruent to triangle CDB. First thing I notice is that these two triangles share a side, so I'm going to mark that side by doing a double tick. All right, so let's see. Triangle ABD, is it triangle or congruent to triangle CDB? Well, those two paths did not have the marked angles and or sides. So first I got to double check if I have either side, 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 or side, angle, side, because those are the only two ways that we know to prove triangles congruent. So here I have a side, then I have a side, and then I have an angle. For this triangle on the bottom right, I have a side, and an angle. That is not the correct order. In order for it to be side, angle, side, it has to literally be a side, next to it an angle, and then a side. Or if I did the other angle, a side, angle, then a side. So this one is no, and you would just say not side, angle, side, or not side, side, side. A double snakes is what this one would be, and we cannot have bad words. All right, the last little theorem here is the hypotenuse leg congruence theorem, and this says if you have two right triangles, they have to be right triangles in order for this to work. Now the reason that it has to be right triangles is because the right triangle is the only one that has a hypotenuse. Other triangles do not have a hypotenuse. So here, what this says is if the hypotenuse of one right triangle is congruent to the hypotenuse of another right triangle, and one of the legs is congruent to one of the legs, then the triangles are congruent by hypotenuse leg. Do me a favor, everybody, and draw a star right here in between these two triangles so that I know that you are actually paying attention and listening to this video rather than listening without sound. So again, hypotenuse leg works if they are right triangles. If they're not right triangles, do not ever say that the reason triangles are congruent is because of hypotenuse leg. That makes no sense because other triangles don't have a hypotenuse. So yeah, that's the third way to prove triangles congruent. All right, these notes were hopefully short and sweet, and thank you for watching. Have a great day. Bye.